everyone. First thing I want to do is share some information with you. What you should be looking at right now is our Canvas class. I hope we are. And you'll notice it's a new module at the top called Final Exam Information. And let's show you what we have here. Here I have a formula sheet. Hopefully it'll open up shortly. And it gives you a list of some of the formulas that we use. It's not comprehensive, it just has major ones. And this one is huge. This one is almost a book. It's a practice final exam with solutions. So what you got to do here, just can I do that a little bit? There we go. What you're going to do here is, if you wish, and it's totally up to you, it's just a resource, it gives you a little information about the final. Our final exam will be in 2 sections. There'll be one exam, but there'll be 2 parts to it. And it'll be a PDF that will appear on Canvas. So it's not in WebAssign, it'll be on Canvas. And its first part is going to be multiple choice, and there's going to be 10 questions. And here is some examples of what multiple choice questions look like. That was about 21 here, but the final exam won't be anywhere near as big as this. It will only have 10 of these questions. And then section 2 will have 10 questions with 250 points. On average, they're worth 25 points each, but yeah, some are 20 and some are 30, right? But on average, 25. And if you scroll down a little bit further, you'll see the kind of questions that you get from section 2, and there are a lot more than 10. But the reason I'm doing this is I want you to get used to the way I ask questions and the way I phrase it so that you know, oh, that's what he means. I think I'm still going here, aren't I? Yeah, here we go. Almost at the end. There we go. Whoops. And here's some partial derivative stuff, essentially. This stuff here is the chain rule, which we haven't done, which we'll do today. And remember doing first and second derivatives? That's what this one is. Now, that's only part of the thing. Now, here are the solutions. Now, when you do multiple choice in the final exam, all I will see written down on a piece of paper is question 1A, question 2C, question 10D, right? One answer for each question. I don't want to see working because you don't get partial credit in multiple choice. So take any shortcut you can think of, guess, if you're stuck, don't matter, right? Put something in. And then in section 2, as you can see, I've got my solutions to that question, and they go on for a long time. There's my solution to question 30. Keep going. There's my solution to question 37, the last question. So this is basically a resource for you. You can use it in lots of ways. Here are a couple of the most common ways. Some people look at this and do it like a big test. Not all at once, that would drive you crazy, but they just do it. Don't look at the answers. You're going to come across some questions that you don't know how to do. It's just normal. So once you don't know what that question is or how to do it, isn't that a good indication that's something you need to practice on? I need to go hunting. How do you do those questions again? What's that question all about? I'm not sure. Now, if you look at the solution, it will give you a bigger clue, but the majority of this, although I might have made a couple of movements just to save space, are chronological. So you should be able to figure out where to find it, you know, in the WebAssign and the textbook, and that would do it. So some people just use it as a test and then they figure out what they got wrong and then they know what to revise. Other people just go straight to the solutions. and read the question and the solutions at the same time. So it's a bit like a revision where you're reading. I know, it's like you're watching the movie and being told what the end is at the same time. So you're just getting the beginning and the end. For some people, that's helpful. So, you know, I'm not perfect, much as I think I should be. So always be on the lookout for screw ups. You know, oh, you put a 4 there and I think it should be 2. Or you put a plus there and it should be negative. If you come across things like that and you've double checked them, if you shoot me an email, I can just go and change it and nobody will notice the difference. I'll just be updating it with the best answers as it comes up. And that actually, that's helpful. If you can figure out where I've went wrong, it means you know what you're doing, right? I always think that's good. If we look at some of these questions, the multiple choice, for instance, I ask questions that you're not familiar with, because one of the things I like about multiple choice is it gives me the option to ask unusual questions, ones that you have to think about. So take an example, question 4. Suppose we're told that all the ANs are positive and that this series, right, converges. Which one of the following is the only one that's wrong, right? So 3 of them are saying something that's true. Now, if this converges, won't that always converge? And the answer is yes. If a whole load of things add up to 42, if you half them all, won't they add up to something? It'll just be called 21. 1 over AN and sigma AN squared and this one. Which one of them is definitely false? B, C, or D?
B.
Correct. D. That doesn't always converge. That will, trust me. If this one converges, won't 1 over it get bigger and bigger and bigger, right? It'll be infinite. Why doesn't that one converge? Well, here's an example. Suppose I did sigma 1 over n squared. Would you agree that converges? Right. If you take the square root of it, don't you get sigma 1 over n? Doesn't that diverge? Now that statement says the square root will always converge. No, sometimes it doesn't. And there was an example of it not. So do you see in that question, there isn't any calculations, there isn't any nth root test to do or integral to find. It's just a thinking puzzle question, which I like. And that's what I do with some, not all my multiple choice are like that. For instance, question 7 is just a standard. Which one will work? Right? So which of these is the only one that converges? And you could tell just by looking. Any guesses? Which one of them in 7 definitely converges? Last chance.
Is it E?
No, but it's yeah. I can understand why you pick E. It looks like it's an integral test, which it is. No, B. B is an alternating series that decreases to 0. Now I know it decreases because isn't 2 to the n going to be much bigger than n when n is really large? And I can kind of tell that every term it gets smaller and smaller. Now I'm not doing that question as a proper alternating series test with all the working. I'm just saying I can look at that and tell that its limit is 0 and it's going downhill, and that's enough to make it converge. And I'm not proving it, I'm just looking at it and seeing. So that's what I mean by you can take any shortcut you like. Question 11 is kind of fun. It's a way to see if you can visualize in 3D. And I don't want to take any more of this time up because we have other things to do. But basically, that's going to be a resource that you will be able to use if you choose to. There isn't any extra credit. If you don't do it, you don't do it. That's fine.
I have a quick question.
Yes.
So for the second part of the exam, is that on WebAssign, or are we just gonna?
No, it's everything's on a PDF. You won't
Okay.
even be near WebAssign. In fact, now that you've mentioned that, on the day of the final, WebAssign will be locked out. There'll be nothing in WebAssign for you to look, because you could basically go and look for a question similar to the one I just did and look at the answers that they give you and, you know, do it that way. And that's not really a valid test of your knowledge anymore. So that will disappear, and everything on Canvas will disappear, except the final exam information. And the final exam information will only have the formula sheet, the Canvas page that has the test in it, you know, the PDF, so you can see what the questions are, and a link to upload your answers into Canvas. So when the day the final comes around, the only things you'll have that were supplied by me will be the formula sheet, the final exam, and a link to upload your work in. So you've got a week to decide what you need physically printed or written down, you know, all your notes, all your extra formula sheets, because my formula sheet's not exclusive, and some people don't just like formulas. They like to write under their formula, this goes here and that goes there, and this is where you get this from. You know, they write little notes to themselves about how to use a formula as well. So you might want to think a lot about getting that done, right? So you might already have great notes, which is great, you've already got, right? But you might be thinking to yourself, yeah, I probably need to do a bit more preparation, so that when the day the test comes up, you're going to have whatever you've got physically written and the test.
You have a question in chat. It says, will the final be timed?
Yes, the final will be 3 hours long. Normally that's plenty of time, but I'm not a stickler for time. If at the end of 3 hours you're saying, look, I've got one more question, could I get another 10 minutes? I'm sure I can make that happen. It's easy enough to adjust the time. So 3 hours is official. It takes, from past experience, after 2 hours have gone, the first person is finished. And then it's every 5 or 10 minutes, somebody else finishes all the way through. You get an extra half hour to upload your PDF at the end as well. So that you could technically count as an extra 30 minutes if you wanted to use 24 of it to finish off a question. But the time shouldn't typically be an issue. Now, of course, if you want to stare at a question for 2 hours, that's your problem, because I'm not going to make the test unlimited, right? If you don't know what to do, go on to another question. Sometimes 10 minutes or half an hour later, your brain suddenly clicks and you, oh yeah, I know what that is about now, and you go back to it and you do it. I would suggest strongly for my benefit, and this isn't really for yours, that you try and keep each question, except for the multiple choice, on a single piece of paper. Because it gets a little bit hard for me to read if it ends up being all jumbled up and so on. Any other questions about that before we kind of get started on today's work?
Will we be meeting on Zoom?
Yeah, I'll be meeting on Zoom to make sure your big brother or little sister's not helping you. Or in your case, Kathy, your dog. Is your dog any good at calculus now, or does it totally switch off when I start talking?
She's napping right now.
Yeah, I have
but
that
I
effect
do
on
have,
students.
I do have an older child who is good at calculus, but they won't be in the room with me.
Right. So Zoom is for that. Plus, I hope it doesn't harm. I try desperately for it not, but you might be able to tell me in Zoom, question 5 doesn't work, right? And I'll go and I'll look and say, oops, that should have been plus 2t, not minus 2t, you know, to make something a perfect square, for instance, right? I may have to, you know, if that happened. So I can simply just say to everybody, hey guys, question 4 should have been plus 2t, not minus 2t, and that'll save a whole load of trouble. So, it can benefit you. Because it's not on WebAssign, you get the partial credit that you would have got normally. But I need to see the working. I don't want, with the exception of multiple choice, right? I don't want to see a big long question that involved, a lot of work, and you just said, "Oh, it converges," as if that is all I was looking for. 2 words. If I don't see why you found it converged, it's not going to get you any points. So you need to show working. Are we good to move on? Right, let's look at a daft little window annoying the heck out of me. And anybody else in the chat I need to? Right, cool. Now, we have got a little bit of tidying up to do, and then we'll start our last section. So, God, we're there. Just paused for a minute there. We've one more section to go. There should be a drum roll or something when that section happens. Anyway, this is still from section 14.3, partial derivatives. I want to show you how to do implicit differentiation, which is questions 11 and 12 in homework. And also want to tell you a little bit about a special question, number 15, which uses what's called Laplace equation. So once those are over with, we'll then start our last section, which is the chain rule. Okay. In question 11, we're being asked to use this technique called implicit differentiation to find these 2 partial derivatives for this expression. Now, implicit differentiation is the same differentiation way back in Calc 1. Can you remember doing the x squared plus y cubed equals 10, and you had to differentiate and find dy by dx? And it wasn't a y equals, it was a mixed up x's and y's kind of thing. It's the same thing here. What we have to realize is that this expression here, when we try and find the partial derivative dz by dx for this expression, what I could do, but I won't, is couldn't I rearrange this to be z equals, right? Just take this and write it down as a function z equals, and then just find dz by dx partial derivative. Instead, we're going to use this technique, implicit differentiation. And essentially what you do is you try and remember when you're going through this, that z is a function of x and y. So how will that work? Take each guy and do a partial derivative with respect to x. This guy gets you 2x. This guy, with respect to x, doesn't he get you a big fat 0? Equals, that's a little bit different. This guy gets you 0. And this guy doesn't get you 0. He would in a normal kind of derivative, right? Because z is not x. But since z is a function of x and y, we treat this guy and only the z guys differently. I'm going to do a power rule. So differentiating 3z squared is 6z. And then I finish with dz by dx. Now hold that thought for a minute, and I'll try and show you what might have happened away back. That's for the next question. Away back in the day. Can you imagine that you were doing Calc 1 implicit differentiation, and you were being asked to find dy by dx, right? So this is Calc 1. Wouldn't you differentiate this and get 2x? Wouldn't you differentiate this and get 3y squared dy by dx? And then you would differentiate this and get 0. Does that ring bells from Calc 1? Now, what would be the next step in Calc 1? What would I then have to do to answer the question, which was find dy by dx?
Isolate the dy by dx.
Okay, so one way of doing that would be, as long as you do it to both sides, it's okay roll. So I'd subtract 2x from both sides. And then to finish, wouldn't I divide both sides by 3y squared? Right. Now that is called implicit differentiation in Calc 1. Now let's return back to this guy. We've done the partial derivative. Now I'm just going to rewrite the thing again because all those little arrows are distracting me, right? And since we're being asked to find dz by dx, you see I'm going to do the same thing. Aren't I going to isolate the dz by dx? In this case, I'm going to subtract 2x from both sides and then divide both sides by 6z. And if, as happens here, I can make it a little bit prettier, I shall. And that's the answer. Does that make sense? Do you understand kind of how we made it happen? How we found, in this case, dz by dx, right? Can I skip the dz by dy because it'll be very similar looking? You get it's pretty much the same question. So that's 11 done. Here's another one of these implicit guys. This is question 12. And just because I want to, I'm going to find the partial derivative dz by dy. Now, when you tell me to find this, won't I think of z now as being a function of x and y, right? So what do we get? Well, I'll start with the original relationship. If you differentiate e to the power of 4z with respect to y, you will get e to the power of 4z times the derivative of 4z, which is 4 dz by dy. Are you happy about that guy? The e to the 4z gets you this mess. Now over here, I have 4xyz. That is not as clean as it looks. Will you try and think of that as being 4xy times a z? Because 4xy has a y in it, and isn't z considered to have a y in it? So it's really a product rule, isn't it? It's two things multiplied because I'm differentiating. So I'm going to do an f dash g plus an f g dashed. And while I'm at it, I'll tidy up this side. F dashed is the derivative of this with respect to y, so that's 4x. Leave the other guy alone. Plus leave the first guy alone and differentiate this guy with respect to y. And differentiating z with respect to y gets us that. So what we've done in this line is we've taken this expression and we've done all the partial derivatives of z with respect to y. Now this one is a little bit harder than the other one, but the goal is the same. Don't we want to get the dz by dy's eventually? So what I'm going to do is I'm going to look at this and I'm going to say, I kind of like where you are, so I'm not going to touch you. And I kind of like where you are, but I don't like you. I'd like you to be over here. So to make that happen, I will subtract 4xy dz by dy from both sides. Are we comfortable with that? Okay, what do you think I'm going to do next? Because remember, the goal is to isolate that guy.
Factor out the dz by dy.
And when we do that, we get this fella, take away this fella, equals this fella, right? And would you agree then that last line is pretty much just divide? Are we good with that one?
Factoring out the 4 as well.
Oh, yeah. Actually, now that I see that, it's better than I thought because they cancel. Imagine this was a test question. And you want to be efficient, right? You want to get all the points, but you don't want to skip lines if you think they're going to cause you an issue. But you want to find the other fella. So I'm going to write this guy down. And we've just found this fella. You are allowed to do this. Would you agree that this function is symmetric as far as x and y is concerned? Couldn't you switch the x and y and it wouldn't change the question? Right, so it's basically, you can say by symmetry. If this is what the partial derivative of z with respect to y gets you, you should be able to predict what the other one would give you. Now, the easy way to do it when it's a 2-variable symmetry is just turn all the x's into y's and turn all the y's into x's. In other words, switch places. Now, if you switch places, do you see how that happens? And the z's are still, right? The z's are like fixed, they don't move, right? And won't this guy become technically yx, but wouldn't you just call it xy anyway? And what you've just done there is, you probably saved a few minutes. Right. Now, just to try and give you an idea, suppose you did pretty much all of this correct, but somewhere or another you lost a sign. Right? You wrote it down wrong, you forgot that there was an extra sign there, and you got that. I see the working. I noticed that you screwed up with a sign. I don't think it was a major mistake. It was either you wrote it down, you transferred it wrong, or maybe you just forgot about it, whatever. And so maybe I'll deduct 2 points. You then say symmetry to me, and your symmetry answer would be that. Agreed? Based on what you thought the answer was. That causes you no lossage of points. Because isn't it correct as a process for your starting point? So it's not like one mistake destroys points all the way through. You get penalized for the mistake, and then I just say, okay, from this point onwards, did they do the correct thing after that? Right. So if you, at the end, chat to each other about the finals, don't do it during the final, but after it's finished and over with. And you say, oh God, I didn't get that. I got something totally different. And then you start, oh God, that's 25 points. I've screwed that question up. Do you know it could be a 23 pointer because all you did is put a plus with a minus, or a 2 where a half should be, the kind of little things. Don't do a major problem because you lose more points if it's something big. And if you use the wrong method, then you're in real trouble. So as long as you're doing the right method and you're not doing any horrendously bad algebra, what would horrendously bad be? That would cause a lot of damage to your points. I'm not saying you get 0 because I know you wouldn't, but you don't want to do something that bad, right? Because that's not a good idea. I don't know if any of you have ever done it. Have you looked at your WebAssign score for your test and freaked out because you get 20? And then you saw what your real score was later on, and you realized that you got a lot more points than WebAssign originally said. I've got something here I can't find. Ah, I know where it is. Number 15, Laplace. Really, a French mathematician, I won't hold that against him, really big in calculus, has got a lot of theorems. He's got a thing called Laplace transform. He's actually got a function, I believe, the Laplace function. And he did a lot of really cool stuff in math. Very bright guy. And this is called Laplace's equation, which is a second order differential equation, but partial differential equation. Second order, of course, are second derivatives and partial derivatives for obvious reasons. And this very, what's the word? Simple looking equation is actually used in a lot of models. It, for instance, can be used very well in heat transfer models. A heat transfer model would look something like this. Can you imagine you've got a plate, and on this plate you had a heat source, and then as time goes by, won't the heat on that metal be different at different points? So at the center it might be 100 degrees, but at the edges it's 30, and it travels from one side to the other, and that's a heat transfer equation. Quite important. I mean, if you've got an engine, don't you kind of want to know where the heat goes and how fast it goes there? So anyway, that was his thing. So what's this question about? There are 5 possible solutions to Laplace's. In fact, there's an infinite number of solutions to Laplace's equation. There are many functions that this is true. And some of them are very helpful and very useful, and those ones get used a lot in physics. Our job is to test each one of them to see whether or not it works. Katie, you went and mentioned the Cauchy sine one, right? I'm assuming that's what you were talking about. Right. I'm going to pick 2 of these. I'm going to pick my first one. And my first one is this guy. And the second one you can give me. So we're going to check, does this work? And if it does, you put a little check mark. And if all of them work, you put 5 check marks, right? So it could be 2, 3, who knows what. And we have a sine x, a hyperbolic cosine y, a cosine x, and a hyperbolic sine function y. And do this guy, and what do you get? You get a cosine x, hyperbolic cosine, minus a sine x, hyperbolic sine. You then do its second derivative with respect to x. So these guys here are really just constants. So you're going to go a negative sine x, hyperbolic cosine. Take away a cosine x, hyperbolic sine. And that's that guy done. And then I'll start again, but this time with respect to y. I'm sure I mentioned it. What's the derivative of a hyperbolic cosine?
Positive hyperbolic sine.
Okay, great. And add a cosine x, and the derivative of a hyperbolic cosine is a hyperbolic. The derivative of hyperbolic sine is a hyperbolic cosine. Do you notice that they don't have change in signs? And if you do a second derivative, then you're going to get the sine x hyperbolic cosine plus cosine x hyperbolic sine. And that's this guy. Now, I'm going to take this guy and add it to this guy. This fella added to this. And if it's equal to 0, we can tick it off our box, right? And if it's not, it doesn't count. So let's see what we get. Would you agree that this piece, when you add it to this piece, kills each other off? And would you agree that this piece here, because it's negative, when added onto this one, which is positive, it kills it off. And so if you added those together, you do get 0, which means you fill it in with one of your dots. Are we good with that? Right. I'll take a volunteer. Which one of the 4 that's left do you want me to do?
The natural log one.
I thought you would. Because you are nasty and you're not nice, and I definitely don't like this class because you do stuff like that to me all the time. You never pick x squared plus y squared. You never do. You always pick that x cubed e to the x cubed y squared. They're always, that's what you're doing.
If we don't do it now, I'm going to be doing it in office hours.
Okay. Okay. That's probably true. Well, I'm going to do something right off the bat, which is I'm using a bit of algebra to make my life easy. Isn't a square root a half power, and can't a half power turn into a half log? And would you imagine that that's going to be easier to differentiate? So that would be my first, do the thing. Right. Now, if you differentiate this, it's a chain rule. So what you get 1/2 over x squared plus y squared times the derivative with respect to x, which is 2x. So the whole thing ends up being that guy. So far, so good. Now, I'm going to do the second derivative. Not so pretty. Would you agree that I need to do a quotient rule on this one? So it's going to be f dash g take away an f of g dashed over a g squared. Differentiate with respect to x, you get 1, leave the bottom 1 alone. Take away, leave the top alone, differentiate the bottom with respect to x, and on the bottom, you just get this guy squared. So you got an x squared, a y squared, take away 2x squared. And you get that. Right, again, imagine this was a test question. Right. I've just found this fella. Would you agree that this function is symmetric in x and y? Great. And since it's symmetric in x and y, shouldn't I be able to figure out what this guy is by using symmetry? In your working, you only need to put in the word somewhere by symmetry. So I know that you're not just guessing, right?
Also, real quick, doesn't that simplify?
Well, you could call it y minus x, y plus x, but it doesn't really help much. So
I mean, if you factor it as a conjugate square, is that what you call it? To cancel with one of the bottom.
It doesn't cancel with anything in the bottom. You might want to check it out, but it doesn't. No, it just doesn't. You get a y minus x, y plus x, but a y plus x doesn't have any effect on that guy. They are not compatible. They don't cancel, if you were thinking that. Right. By symmetry then, what's this guy's second derivative going to be?
Would just be x squared minus y squared over the same denominator.
It will be. If you take this guy and you add it to that guy, would you agree you get 0? Right? And since you do get 0, that means he gets picked as well. Now, if this was a section 2 question, there'd be lots of working, right? But you could at least cut out by symmetry if you see any, right? And that reduces your workload. Imagine it was a multiple choice question. Now, this couldn't be a multiple choice question because there's 2 correct answers, but imagine one of them wasn't there. Imagine that wasn't there, and this is the only one that worked. Or that wasn't there, and this was the only one that worked. When I look at that question, can you imagine that symmetry might be a clue to which one of the 4 worked? And if you said, oh yeah, I think I did a question like that before and symmetry helped, you might then be able to figure out what to do. For instance, I can tell you looking at that one that it's not going to work. I can look at this one and tell for a different reason, although it does have symmetry, but for a different reason, it doesn't work.
X squared minus y squared doesn't work.
Correct. Oh, wait a minute, take it back. X squared minus y squared does work. X squared plus y squared doesn't. That guy gets you 2 and that guy gets you -2 and they do get you 0. My apologies. This doesn't, this does. So I have no idea whether that works. Yes, I do. It doesn't work. So if it was a multiple choice, if you can see, since there's only one right answer, if you find that right answer, don't look for any more. Right. So see if the question was which one of these 5 is the only solution to Laplace's equation? If you find the one that works, don't you just stop looking? Right. It's C. I don't care. There can't be any more correct answers. So, wow, didn't realize it would take us quite as long, but hey, we got 4 days. It's not like I'm going to be too worried. We're going to do chain rule. The first 2 questions, I believe they're questions 1 and 2 from the homework. I guess they put them in chain rule. I wouldn't have put them in there. I would have put them in the section we just finished, but nonetheless. Can you remember on Friday, I showed you a rather cool formula for finding dy by dx of implicit functions? And it was that guy. So it was how you could use Calc 4 to do Calc 1 stuff. So question 1 and 2 are basically questions where you use that property to find dy by dx. So let me try and find the darn thing first. There we go. Whoa. Goodness gracious. I'm going to do question 2 first. I'll do 1 tomorrow because 2 is huge. So question 2 is 8y cosine of x is x squared plus y squared. And we're being asked to find dy by dx. Now, if we did it using Calc 1 techniques, wouldn't that be implicit differentiation of quite a complicated type? Because that would be a product rule, and that would have a 2y dy dx. It'd be messy as heck. So what you do instead is you get everybody on one side and make the function equal 0. And this function we call f. And then I find the partial derivative of f with respect to x and the partial derivative of f with respect to y. And it's partial derivative here. I don't want you to think implicit anymore. Think simple. X is a variable, y is a constant, and then y is a variable, x is a constant. Don't think of x being a function of y or y being a function of x. That doesn't help. So, partial derivative of this with respect to x gets you negative 8y sine x. Partial derivative of this with respect to x gets you negative 2x, and that gets you nothing. If you do it with the y's, you get 8 cosine x's. That gets you nothing. minus 2y. And we are finished. Because dy by dx is negative this guy over this guy. And you'd probably do something with all those double negatives floating about. Do you see how quick that was using partial differentiation? So what would have been a Calc 1 problem of finding the derivative dy by dx of quite a messy implicit function simply just became finding two relatively easy partial derivatives, dividing one by the other, and remembering it's sticking the minus. So I've just been using minus this guy over that guy.
It would be plus 2x, wouldn't it? The negative would distribute all the way.
You all caught that deliberate mistake?
We
But
could
you're
also
right.
factor a 2 out of the whole thing.
Also correct. I was so keen at finishing. Always be on the lookout for style points. You're never quite sure what you're going to get. And I think it's time to say hi, if you haven't already. And I'll hang about for any questions at the end. And we'll see you tomorrow, where we'll do, I think there's only 2 of these darn things, so we'll do question 1. And then we'll be doing what I would call chain rule proper, right? Because that really isn't a chain rule in the usual sense. Okay, who's got our question first? We may not have any questions, but if we do, who have we got?
I do not have a question.
James, what about you? You good?
Good, but I'm looking if I have a question. When you were
Okay.
going through the sheet today,
Yes.
practice, the first question you went through, I didn't quite catch how you came to the answer.
Is this in the practice test or the question?
Practice.
Okay. Right, hold on that thought. I'll have to go out and in, but I can get that. If you get in, Douglas?
No, I'm on WebAssign right now. Sorry.
Okay, no, that's fine. Jason, you getting in?
I'm good.
You're good. Okay, let me have a look at that thing then. So that means I can close off WebAssign. I'll put in the practice final. I'll switch over to that screen and you can maybe tell me or remind me what we were doing. I can't quite remember what question I was talking about when you were referring to that. Okay, here we go. Is it this multiple choice? No, it wasn't. I never did that one.
Oh, I think it's 4.
This question here, this 4.
Mm-hmm.
Okay, so this is a kind of logic question. So there's no math involved. It's more conceptual. Right. So if I know that a series converges and it's all positive numbers, that's just to make this one here doable. Because if the numbers were negative, you'd be in trouble, wouldn't you? So if a series converges, won't half that series also converge? So I know A is true.
Mm-hmm.
If you take this guy and you square it, a lot of people think squaring makes things bigger. Well, it does when the things are bigger than 1. But what happens when you have something that's less than 1 and you square it? Doesn't it get smaller? Right, a half when you square it's a quarter. 1/10 when you square it is 100. So if you imagine all these little guys all add up to a number, won't a whole load of guys that are even smaller than it also add up to a number, right? If you are smaller than something that converges, doesn't that mean that you have to converge? Right? If you're made up of little things that are even smaller than another series that converges, we could say it was a comparison test, right? If you're smaller than a converger, you converge. So that was my logic for saying that one's okay. C, 1 over AN will always diverge. And I can argue this one. Since this one converges, isn't one of its properties that AN tends to 0? Right, all the little ANs have a limit of 0. Well, what happens if you take 1 over something whose limit is 0? Don't you get infinitely big answers? And if you have a series adding up lots of very big numbers that get bigger and bigger, won't that essentially diverge and is guaranteed to? So that was just a thought process of how I figured that out. Now, I guess by a process of elimination, it has to be D. So, I mean, that might be one way you figure it out. If it ain't the first 3, it must be who's left, right? But I can argue why the 4th one is wrong, why D is the one that's not true. It says that the square root of this fella will always converge. And the key word here is always, because sometimes it will, but not always. And the series that I used in my head is I imagined a very simple one, sigma 1 over n squared. So I'm going to switch over to here now and show you what my thought process was doing. Right, I know that that converges. I know it's a P series and P equals 2, so it converges, right? I know that. Now, if I take the square root of that guy, I get that fella, which I know diverges. Well, they said it should always converge. Well, I found a situation where it didn't, so that must be false. And D is wrong, right? D is false. So that's the correct answer to the question, is D.
Yeah, that makes sense. I realized I made a few mistakes. I didn't read that it's a series that converges, and I didn't realize that the AN it's a function goes there. I kept thinking of it as X or something.
Right. Yeah, because AN ends up being n over n cubed plus 1 or something, right? It ends up being a physical thing with n's in it. Okay,
Yeah.
any other questions?
I do have a question.
Okay, what you got for us, Sam?
So this is for test 4. And I wanted to make
I
sure
think you said test 4, but the 4 broke up. Okay, right.
Test.
And what question was it?
So there's 2 of them. The first one will be quicker, so I'm going to do this
Right.
first. So it's number 3. And what it is we had defined the T, N, and B vectors, but I got T and N right, so we can just take the cross product of those 2 to get B, which is
Okay.
what I got wrong.
Okay, so is that what you want to see?
Yes. So
Okay, so can you tell me who T is,
yes.
who N is?
T is 0, 1, 0. And N is negative root of 2 over 2, 0, negative root of 2 over 2. I think I see where I got wrong, but I just want to make sure.
Okay, so we do an IJK because we know that B is the unit tangent, unit normal, right? So we've got an IJK, and we've got a 0, 1, 0. This fella, 0. This fella. Looks like it's going to be 0, but we'll see. I could be wrong. So many I's, take away so many J's, plus so many K's. Okay. Oh, I was wrong right off the bat. This guy, take away 0, gets you that. 0, take away 0, gets you 0. And 0, take away that is an add, so you get that. So I have this guy, and this guy.
Okay, cool. So I got this sign on that last part wrong. That's where I got that wrong. But that,
Right, so when you were doing it, you went 0, take away that, but didn't realize there was a negative at the same time. And
Yes.
that ended up being plus.
yeah.
Okay. And the other one?
So this one, I'm not sure where I'm getting it wrong. It's the first problem. We have vector function RT that intersects, that represents the curve of intersection of two surfaces.
Okay, and the surfaces are?
So z equals 7x squared plus y squared. And y
Is it 1 7x squared and a single y squared, or a combination of the two?
just like you wrote it.
Okay, and?
And y equals 6x squared.
Right, so what I would do here is I'd focus on this one because it only has 2 variables. And I would choose x to be t. And that would make y equal 6t squared. And that would make z 7 lots of x plus y squared. So I get 7t squared plus 36t to the 4th. And that would give me my r of t, the x, the y, and the z.